All right, good morning, folks. We're going to go over some of the questions in quiz 2. Now you'll see that I have the correct answers highlighted here in questions 1 through 8. And I want to point out that most of these questions really are straight memorization. All right, so it's important that the rules that we set out, Kathy and I discussed this, and that we address specific rules that are observed in cardiology regarding rate, rhythm, PR interval, P waves, and the appearance of the QRS. The importance at this juncture and always is to apply those consistently. So this is going to be one piece where you really do have to memorize the features, okay? So with number 1, all of these are correct. So I don't want to spend too much time on concepts that are strictly memorization, okay? So with 2 and 3, 1 through 3, they're all memorization. Same here with 4, 5. Now, the width of the QRS, out of these choices, this is going to be the most correct, B, correct? Now, depending on which books you look at, we talked about this before, your book cites 0.11 seconds as being the outermost limit of the width of a QRS, and other books will point out down here 0.12. And even though this doesn't have 0.04, when a lot of books will cite 0.04, clearly this is going to denote somewhere between 1 and 3 boxes, okay? So bear in mind that in addition to strict memorization, you're also going to be picking the most correct answer out of the 4 you're given, and you have to let your mind embrace that. Even though it might not be an answer you would select, given the 4 choices, you picked the one that is most correct out of those 4 choices, all right? Relative refractory period, yes, this is in the process of repolarization. So when we're looking at this portion of the strip, we know that in the first half of the T wave is the absolute refractory period. There's no way you're going to get another depolarization out of that tissue in the absolute refractory period. Absolute. But in the second half, the relative refractory period, then it's possible to get another stimulus or another depolarization out of that tissue. Okay, so be real clear on that. Relative and absolute refractory periods. The best lead to evaluate an arrhythmia, yes, it really can vary. So there is never one lead that we're going to say is good for all people. And in fact, it depends on what you're looking for that will determine which lead is best to look for that given abnormality. So it's never a good idea to say that there is only one lead for all people. Basic pacemaking rate, can't talk, pacemaking rate of atrial tissue. This must be straight from the book where it says 55 to 60. All right, so let's move forward. All right, so folks, with these questions, most of this is more memorization. So I want to point out to you some areas that I highlighted in green because keywords tend to point us to the correct answer or away from the incorrect answers. So exact multiple of the P to P interval. So again, this is, we have our QRS, and we're looking for that exact multiple, meaning we expect it to show up in the same time frame. And when the next complex doesn't show up in the correct time frame, then that means there is a non-compensatory pause. There is no pause to allow you to stay in the correct rhythm. You just return out of sync, all right? Aberrantly conducted PACs tend to be show a right bundle branch blocks. Down here on 11, a lot of people, if you missed this, it's probably because you didn't pay enough attention to the accept. So any of these tend to have irregular rhythms associated with them, but accelerated junctional does not. So again, watching for the accept. Parts of complexes that are different in wandering atrial pacemaker, that's going to be both the P wave and the PR interval. Because remember, if we've got wandering atrial pacemaker, that means the pacemaker site might be coming from here, in which case it'll take a certain amount of time to make it to here. Or if the wandering atrial pacemaker site is coming from here, it'll take a different amount of time. So again, not only is the P wave going to be different because the origins are from in different places, but the PR interval, which measures the amount of time it takes to get from here down to here, depending on the path it takes, that's going to vary also because the distance the impulse is traveling is a little bit different as well, all right? Now, AV nodal conduction and A flutter, not terribly common to see rates of 6 flutter waves to 1, but it's certainly possible, especially if the rate is very slow. So if the rate is very slow, then there's lots of time to get flutter waves in between the complexes. So if it were a very slow rate, you're more likely to see more flutter waves in between. Uncontrolled AFib, usually at rates between 100 and 200. And then here's why this answer is incorrect. The ventricular response to AFib is always, yes, most of the time the ventricular response is going to be irregular. But whenever you see always or never in the question or the answer, that should guide how you answer. So when you're given a true false like this, if always or never is included in the question, it's certain to be false, just an FYI, okay? And then if always or never is one of your choices for answers, don't select that as an answer because it's not going to be the right one, all right? Now, what I want you to think about is if you have an AFib that is very, very rapid, it's going to appear as if it's regular, okay? And the only way you'll see that it's not is if you slow it down. All right, so just bear that in mind, okay? And we'll pause again. All right, moving on to rhythm interpretation. So let's look at this first one. We know that we have a rate of 130. Why won't this let me write on there? All right, do-over. Apparently this program, once I add too many images, it won't let me write on them. That's too bad because that was a pretty cool little feature. All right, so for this rhythm, we have a rate of 130. When we look at how regular it is, we have what appears to be a regular rhythm. And if you use either your calipers or the little piece of paper that I showed you to mark off the QRSs, you can see that it's regular. When we look at our P waves, we see them here. And really, for the most part, they all look similar to each other. We can see sometimes, like here, this one looks a little pointed. But if you look over the course of it, you can see that really when it shows up, this strange little pointiness, it's not that frequent, and overall your P waves look round, upright, and similar to each other. So they are, we'll just call P waves normal. And then if we look at our PR interval, and we count from here to here, we can see that the PR interval, I'm going to change the color of my ink because it's hard to read. So your P's are normal, and your PR interval is also normal. And then finally we look at the last piece, which is the QRS, and we see that that's within normal limits. It's about 2 boxes. So really, what's the only thing that's abnormal in this? The rate. So this is a sinus tachycardia, because everything is normal except for the rate. All right. Now let's look at 17, and we have once again a rate of 1, 2, 3, 4, 5, 6, 7, a rate of 120. It also appears regular if you measure it out. And then we can look at the P waves. The P waves are really consistent. In fact, they're more consistent than the strip above this. So the P's are normal. The PR interval they all look normal. And the QRS looks great too. Less than 3 boxes, less than 0.11, correct? So if we called this one up here sinus tach, and the only difference here is a rate of 120 instead of 130, but it's still greater than 100, then this also is sinus tach. This one here, this is a hallmark. You can eyeball this. Even though we tell you don't eyeball at this stage of the game, A flutter is probably the only rhythm that you can eyeball and call it A flutter. So, but let's break it down in the chunks that we're supposed to break it down. So we have a rate of 1, 2, 3, 4, 5, 6, 7. Rate is 70. So in all likelihood, that's coming from some pacemaker site above the ventricles, right? The rhythm, I'd have to measure it out, but it looks to me to be somewhat regularly irregular, so that's an abnormality. P wave, there's flutter waves, but no actual P waves. So therefore, there is no PR interval that we can measure. And then the QRS is within normal limits. So this is A flutter. Okey-doke, moving on. Okay, so let's move on to 19 here. And we're going to subject this strip to the rules like we always do. All right, so we have a rate of 1, 2, 3, 4, 5, 6, a rate of 90. The question is it regular or not? And it is irregular, and it's irregularly irregular. And if you measure it out, you'll see that, okay, which is what I just did. Rate regularity. All right, next thing we're looking at is the P wave. Do we see a discernible P wave? Now, I'm going to guess that a lot of you are desperately trying to call that a P wave, or you're looking at that little whatever you want to call it and thinking that's a P wave. Some of you are probably thinking that's a P wave, but really, is there anything organized enough to call it a P wave? No, there is not, okay? Now, we know that I would call this perhaps a T wave, and that's a T wave. So I know that there's repolarization going on. So these are all T's right here. And that's often what I'll do, is I'll find my QRSs first. If I'm stuck on something, if I see a whole bunch of mess in between my QRSs, I'll start looking for features I do know first, which the QRS is always something I can find, right? And then I'll start looking for a T wave, because I know that unless we're talking about a VTAC where there is no T wave that I can discern, that we're going to see a T wave, right? So I'll look for my T waves, and then once I take out my QRSs and my T's, I look to see what's left, because there should be P waves if P waves exist. And if I don't see anything discernible, and again we have a T wave here and a T wave there. Now, do you see anything left that you could basically say shows up every single time that you could call a P wave? No, there's nothing discernible. You can't see a P wave. Not discernible, or not in appearance. So if you don't have any P waves that you can see, then you don't have a PR interval either. And yet the QRS is still normal. So if we apply, and we'll put within normal limits just to make it shorthand, if we apply our rules religiously, we know that if we have a rate of 90 that's very irregular with no P waves that you can discern and no discernible PR interval, but you still have a narrow QRS, then we know this is atrial fibrillation. And in fact, the fibrillation is so fine you can't even see any fibrillatory waves. And that is often what the case is as well. So the big giveaway here, excuse me, is the fact that it's irregular and the P waves are not discernible. All right, for 20, once again, we're going to do what we always do. We're breaking it into chunks. And you're going to have to memorize the features of a sinus rhythm and these other rhythms as well so that you can apply them. So some things is applying your knowledge, which is rhythm interpretation, but to be able to apply it, you have to memorize the knowledge, all right? So 1, 2, 3, 4, 5, 6. So we've got a rate of 70, and we're going to determine a regularity. And this is irregular. Now let's look at our P waves. And I can see my P wave here and here, right? You can pick them out. And what's interesting is they all look the same, right? They're all round, they're all upright, and they all look pretty similar to each other, if not almost identical. So the P waves are round, and we'll just say normal. So that means we're going to have a decent PR interval, or at least a PR interval in existence. So let's measure it. We've got a PR interval that starts there and ends there, starts there and ends there. And interestingly, here our PR interval looks to be about 1, 2, 3, about 3 boxes here, 1, 2, and about 4 boxes here. And again, about 4 boxes there, and somewhere around 3 here. So the P interval is between, it's within normal limits, but they're not the same every time, okay? And then when we look at the QRS, QRS looks fine. It's within normal limits, right? You've got it definitely between the 1 and nearly 3 boxes, so we'll say within normal limits. So we have a normal rate, but it's irregular. The P waves are clearly sinus in nature, because they're round and they're upright. The PR interval is a little irregular. So we have what's clearly something that's originating in the sinus somewhere, but it's irregular. So this is a sinus rhythm that's irregular, so that means it's a sinus arrhythmia. Okay, all right, moving on to 21. So we have a very fast rate, 2, 3. So it's a rate of 190. It appears to be regular. P waves, we're not really able to see them. Okay, so if you're thinking this is a P wave, it is not. It's a T wave. These are T's. Okay. And it's very likely that our P waves are just going to be buried in our QRS. So P's not discernible. PR interval, therefore, is also not discernible. But our QRS is within normal limits. And the big giveaway is that we have this rate. It's greater than 150. We can't make out any other features, so it gets the magic umbrella term of SVT, supraventricular tachycardia. Alrighty, moving on to 22, we have a rate of 40. This appears to be very regular to me. If we look at the P waves, we can see a P here, and a P here, and a P here, and look at them. All of them look round, they look upright, and similar to each other. So we're going to say the P's are within normal limits. The PR interval begins here, goes to there, begins here, goes to there. And the PR interval, if you measure it out and you count your boxes, you'll see that that also is within normal limits. And then the QRS is nice and narrow, and that's also within normal limits. So the only thing that's abnormal is the rate is slow. So a rate less than 60, this is sinus brady. All right, just for your edification, if anyone's curious, if you look at the QRS here, you'll see this slight little negative dip. That's the Q. The positive deflection is the R. And then you'll see that it dips below the isoelectric line. So this is a true QRS. That Q wave is not at all pathologic, so we don't worry about it at all. But that, by definition, would be a true QRS. And again, if we don't see these features of the little dip negatively, either before the R wave, after the P, or after the R wave and before the T, we still will call it a QRS, but I just wanted to call your attention to those features. All right, so let's move down to 23. All right, so with 23, we have a rate of 50. It appears to be regular. And we do have P waves. There's one. And there again. But what's notable about the P waves? The P waves are upright, but they're not uniform. Let's look real closely at them, okay? This one is a nice round upright P wave right here. All right, let me use a different color ink so you know which one I'm talking about. This one is nice and round and upright. This one, you can barely make it out. And if you really wanted to be paying attention to detail, you could see that the PR interval looks a tiny bit different also. But definitely the appearance of the P is different from this one. And this one doesn't look like the other two. All right. This one resembles the one before it, but not exactly. So basically the PR interval, you'd have to measure it, but it looks to be within normal limits, but irregular. Now your QRS, the QRS is a little bit tricky here because it begins right here, and then you can kind of see that it starts to end in there. Now that looks really like it might be too wide, but if you count it, it's really right at the 3 boxes. Okay, it looks wide, but if you really count it out, you'll see that it falls right at the 3 boxes. So some people would argue that it looks wide. Nonetheless, if we look at our rate and then the P wave is going to be the dead giveaway, because the P wave is different every time and it makes the PR interval a little different every time. So this is wandering atrial pacemaker. All right, that one was a tough one. All right, let's look at 24. So we have a rate of 1, 2, 3, 4, 5, 6, 7. A rate of 70. Let's see if it's regular. And it is regular. All right, so let's look at the P waves. And you might be thinking the P waves look a teeny bit pointed, but really they look pretty consistent compared to each other. So we'll say they're round-ish, they're upright for certain, and they all look similar to each other. So we'll say they're consistent. And then if we look at the PR interval, we'll find that it too is consistent and it's within normal limits. And then the QRS looks fine. It too is within normal limits. So everything is normal about this. So it's normal, sinus rhythm. Okay, and looking at our last one. So we have a rate of 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so this last one, I had to look at it. It was a little bit tricky. I want to draw your attention to this first complex. Is the entirety of this complex in the 6 seconds? It is not, right? The QRS is, but, and part of the PR interval is, but the entire P wave isn't in there. So this would not necessarily be counted in the rate. So if we look at the remaining complexes, we have 8 complexes in here. Yes? All right, now let's look at the complexes because they don't look the same. Now this one here, look at that P wave. It's very, very pointed. If we look at these 2 QRSs, we can see that the P wave looks pointy-ish, but they look the same as each other. And when we compare it with this P wave, we can see that this one looks the same as this one. These two look the same. So let me change the color of the ink so it stands out a little bit more. So these P waves look the same. And then these P waves look the same. Okay, so where else do we see a P wave that looks like that? We see one here, we see one there, we see one here, but this P wave looks like the other ones. Those are premature complexes. And you can see that every time they show up, the rhythm gets messed up. We see a nice spacing between our QRSs for these complexes, but when this premature atrial complex shows up, it interrupts the regularity. So this it's irregular. Because of these premature complexes. So I marked this up because I want you to see that each number here represents a second in time, so that these boxes in between denote the entirety of that 1 second. All right? So if we take this complex out, that leaves us with 8 complexes, but 3 of them are premature. So that leaves us with 5 complexes in the 6 seconds, which actually gives us a rate of 50 in the underlying rhythm. So the underlying rhythm has a rate of 50. Can you see that? Because we know that this is a premature complex, as is that, as is that. We toss this one out because the entirety of the complex did not show up within the 6-second window of time. All right, so what is left that with normal complex is only 5. So that means it's a sinus Brady. Yes? And then when we look at these premature complexes, we know that they're early, and because they're they have pointed P waves, let's write that out. The premature complexes, what's notable about them is their P waves are pointed, P's are pointy, but the QRS is normal, and the P waves are not only pointy, but they're upright. If they were inverted, we'd call it a junctional complex, a premature junctional complex. But they're upright and they're pointy, so this is a sinus Brady with premature atrial complexes. So yeah, that one was a little bit tough because I'm going to wager that some people called that underlying rhythm a normal sinus rhythm. And largely that's going to be because they counted that first complex as part of the rate, and they counted the premature complexes as part of the rate as well. But when we take that complex out and we take out the premature complexes, we arrive at a rate of 50. All right, and then we note the presence of the premature atrial complexes. Okay, I hope that helps. We'll see you tomorrow. Take care.